Assalamu alaikum. My name is Muhammad on Munir, roll number 21T05, and our instructor is Dr. Muhammad Jamil. In this video, I will discuss about Lab 2 of DSP. So let's begin with task 1 of Lab 2. In task 1, we actually uh, plot a discrete function. So first of all, we have three constants defined as n0, n1 and n2, which are valued with -1, -3 and 3 respectively. -3 and 3 basically is the range of the plot. So after that we have n vector range from n1 to n2, and we have x which is fed by a condition n minus n naught greater than equal to 0. So for discrete plotation we use temp command, and after using this command we get an output as shown in the figure. In this figure, as we see that the range is from -3 to 3. So moving to a task 2, which is same as previous task with some differences. First of all, we define three constants n0, n1 and n2, which are valued 1, -5 and 5. -5 and 5 are the range of the plot. Similarly, we define our vector from n1 to n2, and x which is fed by a condition n minus n naught is equal to 0. For discrete plotation we use stamp command, and in the figure we seen that we only found one impulse on one which is fed to our condition. So moving to our task 3, we have two constants n1 and n2 valued as -3 and 3 respectively, which show the range of the plot. We use n, which is a vector range from n1 to n2. We define x 3 multiply 0.5 the power n, and we use temp command for discrete plotation. After that we get an output something like this, which is exponentially decay. In second part of this task, we have two constants n1 and n2 valued as -10 and 10 respectively, which is actually the range of that function. And after that we define n, which is our vector range from n1 to n2, and we define x, which is our cos function, and use the stamp command for discrete plotation. After that we get an output something like this. In this figure, as we seen that we found both upper and both lower discrete plots. The reason is that we know that cos has sinusoid function, which gives both up and down plots. So moving towards task 4, we actually plot unit impulse. So for that we define a function x is equal to unit impulse x naught, x n1 and n2. We define a vector from n1 to n2, and define an x which is fed by a condition n is equal to n naught, end of our function. And for calling our function, we call our function x is equal to unit impulse, give some values 0, -5 and 5, and use temp command to plot discrete graph. After that we get an output only on one plot, which fulfills our definition of unit impulse. Moving toward task 5. In task 5 we plot actually unit step. For that we first of all define function and then use if loop n naught is equal to 0, and then end up our function loop, and then define our x which is fed by a condition and greater than equal to n naught, and then end up our function, then calling our function, define some values, and then use temp command to plot our unit step which is shown in the figure. So moving to our task 6, we actually add the two function unit step and unit impulse. For that we first of all define n, which is our range of the function, that is -3 to 3. X1 is unit step and x2 is equal to unit impulse. Then add up both these functions, unit step and unit impulse, and then display. For display we use display command. Similarly, when we add three functions, unit step, unit impulse, and then unit step, then add up these functions and then display, so we get an output of these two functions, which is our discrete flow. So we get these outputs. So moving to our task 7, we actually flip our function. So first of all we define a range from -t to 3, then define a array, and then flip this array, subplot, and then use temp command to display discrete function, then give subtitle which is original signal, then again use subplot, then stamp, and then give title flip signal, and then we actually give an output something like this. Moving to our task 8, in task 8 we actually define the signal array 1 2 3 4 5 6 7, then actually we scale our signal, so we give scale factor, that is 2, then give scale signal, plot the signal, then give hold on, then plot scale signal, and then use some legend. After that we get an output something like this. Moving to our task 9, we actually shift our function. For that we first of all define time, then define our function, then shift our function, then use plot command, hold on, then plot, then use legend. After that we get an output something like this. Moving to our task 10, in task test we actually uh, used to find a zero hold order function. For that we first of all define line space, then some define frequency, then define our function which is sine function, then define time, then use frequency formula, time formula, zero scale, then starting for loop, then end up our for loop, then use subplot, plot, give subtitle, subplot again, then use tab, then some give title. After that we get an output in continuous as well as in discrete form. Moving to our task 11, in task 11 we have an input signal, that is 1 2 3 4 5. We define time 0.1, then we define n output signal, then starting for loop, and we define output signal, then using subplot stem function for defining discrete function, then use title, then using subplot, then give some title. After stimulating we get an output input signal as well as output signal. These are tasks are the for today's lab. Meet you in the next video. Till that, watch and subscribe my channel. Thank you. Allah Hafiz.